Yes.
Yes, sir.
Yes, sir.
Thank you. So, good morning and welcome everyone to your, I think it's first class on Triple E 499P.
Sir.
Okay, so today I'm going to just give you a brief overview of what uh, you're going to learn. It's not that you're going to learn many things from that lecture, but you're going to get an idea what you have to know. So that means whatever the topics that will be covered, you know that you have to learn those topics. You know you have to learn those terms that you're going to encounter a lot throughout, or at least in throughout your FYDP journey. That means you need to know those things in P and then in D also. Then you're going to implement them in your last semester of FYDP, which is FYDP-C. So anyway, so as an engineer or engineering, to in your case, the aspiring engineers, you have taken enough courses, so where you encountered the concept of designing things in course level. I can say about my own course. Let's say that the course that I take is triple 205. So there is a CU, course outcome, CU3, which is a map to PO3, PO3 or POC, which is design. I'm sure all of you had to go through this process, that you had to design an amplifier, and so that satisfies certain conditions. So from that, this is the first time probably you encountered the concept of design, that you have to design something. Apart from that, all the things we did is just analyzing things. I give you a circuit. For example, if you take DC circuit, you have the complete circuit. You need to find out what are the parameters. It's the kind of analysis. What are the parameters you have to determine? Say the current through the resistor, voltage across different uh, different elements. Okay, and then we learn different techniques to do these things. So same is true for DC circuit, AC circuit, device, electronic circuit too, and all the other courses. So you mostly become proficient in doing analysis. Design aspect wasn't coming that much. But as an engineer, we need to know how to analyze things. At the same time, the most important responsibility of an engineer is to design things. What is design? Designing is something that the you encounter a problem. How are you going to solve this problem? Elevate this problem. Okay. So you will see design everywhere in around us in human level. You would notice, if you have the opportunity to see how the birds build their house. Have you ever noticed that even a simple sparrow? So if you find some in your building corner, they are going to start building their house. Uh, they bring in their big, small uh, wooden stock, and then they put them together. Okay, and you notice that not only that they build something, it is durable. It follows the every and engineering things it requires to follow most of them. Of course, they don't have any electricity, they don't have Wi-Fi and others. But in terms of maintaining the stability, the security, starting from selecting the location, starting from and then building the the houses itself, it's amazing. It's really amazing. But the question is, how do they know those things? They don't learn engineering. Okay, and they don't even have the ability to think. Another example could be what? Another example is, have you ever seen ant colony? So
Yes.
they make layers. They build layers after layers of things underground. It's colony. Now it has become a, uh, a subject on its own right. That is called biomimicry. If I write it down, so I can just. Okay, I need to share the slide. First of all, I need to share the slide. So the entire field is known as biomimicry. Have anyone heard this term biomimicry?
Yes, sir.
Mimicking, it is called, it's essentially mimicking the nature. I am not sure about the spelling. Nowadays, we are don't care about the spellings because there are people, there are things who are there to correct your spelling. So it's biomimicry. So now architects, they use uh, the concept of ant colony to build things. So the question is, how do they do things? They are not engineers. So they do it, probably this is the formation of bird nest. It happens over thousands of years. They do something, they make some mistakes, and those the bird nest that wasn't doing done right, they don't survive. The plain of thing is that it's such kind of Darwinian things. They don't the things that can't adapt, they don't survive. So similarly, those and then somehow those things that get imprinted in their gene, so they know that this is how they have to build the house. Okay. So that is in natural level. But even in human level, from the last 1,000 years, we have got many invention, many prominent inventions. Okay, starting from uh, pyramids. It's also amazing how pyramids are built. And then ancient Roman people, they're tremendous engineer. The road they built still survives. Unfortunately, the road that we built, it doesn't survive one monsoon. But the streets, the aqueducts, all the things they do, they survive for 1,000 years. And then Indian civilization, and then we have the Muslim civilization. It's you would, if you ever noticed, I'm sure you have got the opportunity to see those uh, beautiful structures and others. They didn't know engineering. They didn't know civil engineering. They didn't know mechanical engineering. Of course, there wasn't an electronics there. So how did they do this thing? So basically, it is empirical. This was an empirical method. They do something, they make mistakes. Okay, try it again, try it again, try it again, until they get it right. Okay, and this knowledge, once you learn this thing, it is passed down to your generation. So once you develop a knowledge, all you need to do is probably the knowledge that right now, the knowledge that we have, it has been accumulated over thousands of years, but we take it for granted. And then I tell you, okay, pass it to our next generation. Then we make some certain changes, a little bit of change to that things. It become perfect. Again, we pass it to our next generation. So we're blessed in number of ways. The thing that we enjoy, even starting, even to the things you don't even consider, that the cooking food. Why do you have to cook food? No other, not any other species cooks food apart from us. Even our closest cousin, they say in Darwinian theory, I just that the chimpanzees, they don't cook food. We do cook food. We cook food because of that we become smart. They say that, well, the theory that this is how it goes. Let's say, because uh, since we cook food, we don't need to spend much time digesting them. Cooking food essentially means as a certain part of the food has been digested outside your system. For example, let's take meat. Okay, so if you don't cook the meat, so the amount of time, amount of enzyme, amount of time it requires to digest them is enormous. For example, the chimpanzees, they have a very strong jaw, because you have to chew them, grind them into small pieces. This is the process where you're going to start your digestion. So breaking down all the proteins, amino acids. So they need a strong jaw. Okay. So roughly, once it take a meal, let's say they say that, and their guts is quite big. They say that roughly it takes 4 hours to digest. But since we cook food, since as soon as we started to cook food, the time to digest them become much reduced. So much reduced. What is that? What is the? Let's say this is the theory. It's like the theory is very fascinating. Because that means that we don't need to have a very strong jaw. So that allows us to grow our head. The brain of human being become bigger. And once your brain starts to get bigger, you have you can understand you become intelligent. So that's some scientists said, they said that, well, an invention of fire made human what we are. Anyway, my point is that, so there are trial and error way things have been done so far, but things change slowly. Since new technologies are emerging, new things are being invented, the people started to develop a process as to how to solve the problems. We still can solve problems using trial and error method. We don't say that we are the only, just we have the sole responsibility to design things. There are people who doesn't have the engineering, they still design things. For example, um, Edison, you must have heard. I'm not sure whether it is a story or it's a real time real real situation that happened, that he's probably tried with 100 times to with the different materials to make a bulb. Edison is one of the greatest inventor. Yet what he had to do, he had to do trial and error, trial and error. He tried with different types of material, and then finally he got lucky with, well, after 100 times. You don't say you get lucky, but um, it clicked. The bulb was invented. What does that mean? He didn't know the theory. Theory is developed later. The science came later. Technology comes first. Technology, most of the time, most of the system, technology comes first. Now, if you go to the physics department or take physics course, you learn many fancy scientific theory, such as thermodynamics. Okay, thermodynamics and others. Let's say the pressure theory of pressure. Those people who invented the steam engine, they didn't know thermodynamics. They didn't know all the theories, physics theories. Those theories come because of those steam engines. I was reading a book on. I was really fascinated. I always found it fascinating about the steam engine. How it came about. What are the reason? If you look at the story of steam engine, it's a really very important, very you will find it really very encouraging. On its own, it's a very interesting invention, and the reason it came in England, they somehow discovered coal. Because of its geographic location, there are places the coals are available, and the coals are not so deep. The coals that is found in England were not so deep in underground, but it was very close to some of the closest to water sources. So as they started to uh, mine coals and they go deeper, so this mine is inundated with water, filled with water. So they find it, they encounter a problem. The problem is the coal mine. As you remove or mine coals, of course you have to go deeper and deeper and deeper and deeper and deeper. It's not like that as you mine coals, they will come to you. So they don't come to you, you have to get to them. So the mine gets deeper and water fills in. So you need to evacuate the water. Then it's a problem. So then you can say it's an engineering problem. It's a real problem. It's not like our fancy FYDP Tripoli 499P problem that we're going to learn. This is a real problem. There are money involved. If you need coals are required for uh, uh, required for burning, provide heatings and others. So they found out that if they can pump the water out. But there is also limitations. When it comes to pumping, they found out that naturally, if you create some vacuum, somehow you create let's say some vacuum, in it you can remove water. And this is the thing that we all experience. If you take a straw, you just simple take a straw. I think you must have played with this thing a lot. You take a straw, okay, okay, এভাবে যদি দেখালে সেটা ভালো হবে, straw, you fill it in the water, okay, and then you with your fingertip you close it and take it out. You'll find that water does what? Water doesn't fall anymore. So water, if you take it out of the water, you find that you still your fingertip use water filled to the tank. That's an observation. It's a natural observation. So what happens is that as soon as you dip it in, water gets in, and if you close the top, so the amount of the pressure air reduces, and then air pressure, environment vacuum is created. So because of this air pressure, the water can rise up to certain level, but there is a limit. So naturally, how much water? This is a mathematical calculation that they observe that I'm not sure the entire number. It could be subtle. So it's not more than 30 meters. So naturally, this is the maximum amount of water column height could be more than 30 meters. So then what happens if you go below 30 meters? So that leads to the invention of steam engine. We heard that it is who invented steam engine? Can anyone say? আপনারা কেউ স্টিম ইঞ্জিন কেউ ইনভেন্ট করছে নাম শুনেন নাই? ওকে, জেমস ওয়াটের নাম শুনেছেন?
জি স্যার। Yes sir.
Well, although they say it's a James Watt, but it's not the Watt. Watt is coming from what? This Watt, we have to use the term Watt every time. Kilowatt. Watt. Okay. Energy per unit time. It's not James Watt, but he modified it. And he was a very good interpreter. He had to spend around 15 to 20 years to make it perfect. So just remove those problems. Anyway, the main objective is that in those days they didn't have the formal uh, training. They trained, of course, they trained as they call is uh, what is the term? I forgot it. Not anything. বাংলা বললে শিক্ষানবিশ. What is the English term? I can forget it. Just শিক্ষানবিশ. বলতে হবে. I cannot go to the chat box. Ah, apprenticeship. Apprenticeships. In those days, it's a kind of storytelling. So I'm going to discuss the things later. In those days, they had engineers, and they didn't learn engineering to. They didn't have an engineering university. They didn't have an engineering degree. So they had engineering, but how did they learn it? It's a trade course. It's a skill they develop becoming an entrepreneur. Entrepreneur. Sorry, again I forgot.
Sir, it's apprentice.
Apprenticeship. Let's forget it. Apprenticeship. So apprenticeships, they would spend time, I think 7 to 9 years with one of those expert craftsmen, 7 to 9 years, and you had to pay money. They would not give you money. The same thing you would notice, all the trade, for example, all the skills they they we they have in our country, starting from, let's say, skills to repair your bicycle, skilled electrician, the person who comes to your house to fix your AC, okay, the plumbing, all those trades, all those crafts. How do they learn? Even the electricians, you become engineer, it's become a subject to joke for everyone. And you are engineers, you can fix your computer. You are a computer engineer, you can fix your computer. You are an electrical engineer, you can fix your uh, the microwave. Last night uh, there was a fan. The plug got disconnected. It took me around 30 minutes to fix it. Reconnect it. So it becomes a joke for us. You're going to experience a lot that people will be so, তুমি কি engineer হলা, এটা শিখতে পারলে না, ওটা শিখতে পারলে না. So this skill, apprenticeship is there. আপনারা দেখবেন, those people who you take it to your microwave oven to fix it, they take it, they open it, they have no idea how it works, but they can fix it. The same way, in those days in England, one person had to spend uh, 7 to 9 years extensively, and it's a really also very interesting. It says, and then there are people who would not allow more people to join their guild. They used to take a guild. Every profession have their guild. আমরা এখন শুনি কিসে writers guild, editors guild. At that time it was the guild who protect the interest of every profession. So let's say those people who learned the guild for that time, the chronology means ঘড়ি, the skill about building clocks, because the England at that time was seafarer country. Okay, that needed good clock, an accurate clock. So this field develops, and there is a guild developed around it, so that you will teach people who wants to learn the art of building and fixing clock. And you have to spend 7 to 9 years with any of those, from very early age, let's say 12 years to 20 years. Day and night you stay with them. You would not get anything out of them. Or rather, you have to pay money to them to learn it. And it's very exclusive. They would not just take anyone. They would make sure the members doesn't increase. Okay, so they didn't want competition. So James Watt spent around 7 to 9 years in one of the guild in London. He's from, I think, Edinburgh, Scotland. And of course, some of them not only learn the skill, but they have the ability to invent. So James Watt was one of those. And then he was working on 15 years to make it perfect. Anyway, my point is that, আর গল্প করব না. So my point is that the thing that he invented, one of the biggest invention in for the modern civilization to come about is steam engine. You have steam engine, you have train, you have uh, steamboat, you have electricity, everything that comes from steam engine. That's the spark, from which it only progressed. Right now, we're sitting here delivering a lecture in front of you. That's the sort of beginning. And again, it came from what? It came from a simple engineering problem. What is the problem? We have the mine which is filled with water. It is required to remove the water efficiently. So the engineering, everything comes from engineering problem. We have to keep this in mind, because at that stage, uh, I'm 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 a chair of one ATC. My ATC is 4, and I've been in this position since we have introduced FYDP, and then since then many groups completed their FYDP with me and also with other faculties, ATC members. So every time the new groups comes in, they are asked to bring their own problem, own topic, which is quite normal, it's quite okay. So we don't see the things in terms of engineering problem, because you don't get the lesson at the first stage. So you have to think it's engineering problem. Okay. So what is engineering design? So it is apart from those days, nowadays it has become a systematic, intelligent process in which generate engineers generate specify engineering problem. Either you generate a problem or specify a problem, and at the end, you provide an evaluate solution. It starts with a problem, and you provide a solution to the problem. Whose forms and function? When it's forms, it means the physical shape, and function means it's what it does. Achieve clients or users' objectives, client's objective and users' need. So when it comes to the problem is something that an user and client say, I need something, I want something, there's a need. In his day-to-day business, he feels that he needs something which requires a solution, and he doesn't have the required knowledge, training to provide the solution himself. So he goes to an engineer. Okay. So what is the aim? Aim is to solve clearly defined problem. And then when you define the needs, there must, at the end of the, once the engineer provide the solution, it must satisfy a specific sets of requirements and constraints. So the needs in user's term is broken down to certain amount of requirements. Okay. So for example, I can give you a very good example. This is the same example I think I give is, for example, someone comes to you, then he says that I want something that gives me wind or air so that I don't feel warm. গরম যাতে না লাগে, কিছু একটা করো। So he doesn't say he requires a fan or AC or other forms of, you know, devices that takes heat away. He says that I want to get cool. Okay. তখন আপনি যদি then he comes to you, you probe it, you want something that, if it rotates, that blows air, you say, "Oh, yeah, yeah, I want something like that." Or সে বলবে যে okay, it has to blow wind very fast, heavily, 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 fast. তারপর তারপর বলবে যে it should cover অনেক অনেক জায়গা নিয়ে থাকতে হবে, অনেক জায়গা নিয়ে, অথবা হাত দিয়ে দেখিয়ে দিল যতটুকু পর্যন্ত হলেই হলো, so the coverage. You see, so none of those his needs, it's all of the needs he is referring to is very vague. It's very vague. So what engineers does is that to take those vague terms and they try to quantify it. So they are set as requirements. Okay, and then say they also maintain some constant. Okay, we're going to learn about what constants are. Again, this engineering design, they are in fact multidisciplinary in nature. So you have the civil engineering department, you can have the mechanical, electrical department, they can work together. On top of that, so not just about making things work, but doing so efficiently, ethically, and sustainably. So once you ensure that the things are working, then you need to, of course, while you are providing the solution, you need to consider that this is done efficiently. I don't want to spend that much money, okay? And it has to be done ethically, and it has to be sustainable. So this is our basic engineering. So then it's a process. Like I said, it's an intelligent, systematic, and intelligent process. So what is this process involve? First of all, you have to identify a problem, and based on this problem, you have to do some background research. Not only background research, all it involves talking to different stakeholders. The stakeholders, there could be numbers of stakeholders. The stakeholder could be the user or the client himself. Probably he's going to build a fan, not for himself, he want to sell it to the market. So the stakeholder here is the owner of the fan who comes with the idea and who wants to sell it to the people, so as well as the people who are going to buy it. Okay, so there are lots of peoples are involved, lots of groups are involved as an stakeholder. So you have to do a background research, involve talking to the stakeholders. You have to see what are the state of the art, what are the current status of the fan. You have to, in terms of business purpose, in terms of technology purpose, what are which technologies they are using. You see, you don't need to reinvent the wheel ourselves. The wheel is there, we have to just use it. So when it comes to introducing another fan into the market, doesn't mean that we have to use completely different theory, okay, unless it is absolutely necessary. We may use the existing technology. So that's called innovation. We don't need to invent. Innovation. Okay, after identifying the problems, doing the background research, you have to formulate the problem statement. So we're going to learn how to formulate the problem statement. Then we have to define the scope. Then we have to set the objectives. Okay? And then we have to construct the requirements. Then determine specification, do functional analysis, and then we evaluate the design and decide. So this much we are going to up to P. This is our in B, and this is in C. So from here to B, so we're going to somehow cover up to this. Okay. First of all, problem statements. Again, আমি আপনাদের কি বলেছিলাম? I said that once you, after taking this course, you're going to learn what you have to learn. Because all all the heading that you see here, you have to put them in your concept note. So there is a thing that you have to write down in concept note. What is problem statement? So you need to know what is the problem statement is. So there is a structured way to define problem statement. It is a clear, concise, and specific description of issue, need, and challenge that design projects aim to address. So problem statement must be clear, must be concise, and specific. Like I have already said, it starts with a very vague notion of what needs to be done. Remember, I said your client, your friend comes to you, I want the fan to be blowing wind heavily. It's a vague statement. হাত দিয়ে দেখিয়ে দিলে এতটুকু জায়গা আমার আলো বাতাস থাকতে হবে, এত খুব জোরে ঘুরতে হবে. So these are the term very vague, but and it's bound to be so, because the general people, they are not trained with those engineering terms, so it has to be vague. Again, client statements ill-defined, open-ended problem. Ill-defined. It must be ill-defined. And that has to be, this is the reality, ill-defined. Ill-defined means it's not like that. So whatever he says, you understood it quickly when you first set it. So let's say you sit with the client to provide a solution for them. We are going to have a discussion. He discussed things. He knows he wants something. He doesn't know the other part. Okay, just a second. So he doesn't know the other part. So you are going to take notes. You will find out that there are plenty of gaps in his statements. He could not define the problem properly. So what you have to do, you have to probe it. Tell him, from your expertise, you're going to ask questions. Is that what? Is that what? Is that? So maybe he's going to respond it. Maybe he will be unable to respond to those queries you are going to make. So that makes the problem ill-defined. Okay. So client statement could be ill-defined. And open-ended problem. Open-ended problem is he's not going to tell you how we're going to solve it. It could be of any types of solution. So that means, since it is ill-defined, in order to write down the problem statement, it has to be clear, concise, and specific. It requires extensive background research. Okay, and the problem statement describe a gap between the current state and the desired outcome. So in the problems, we expect that if you want to introduce a new fan into the market, you have to add something new somehow, even if in terms of cost. You have to so that means, so there is a gap. Let's say all the existing fan that they are missing some. It's not missing things that could be improved. For example, the fans that we have got in our Brack University building. Did you notice one of the features which is quite unique to those fans? Can anyone tell me what are those features?
Sensors.
Sensors are internal thing. Outwardly আপনার কোন ফিচারটা আপনাদের চোখে পড়েছে?
Oh, so it rotates both ways.
It rotates in both directions. Isn't that a unique thing? So those people who built those fans, they said that, okay, I found a gap. What is the gap in the current state? The gap in the current state is that all the fans are rotating in one direction. Only blows air. It doesn't suck air. The fans that we have got in our Brack University, it is not a decorative purpose. It doesn't serve any decorative purpose. It has an utility. You see, in your classroom, you would find only one fan. They're designed in such a way that rotates in opposite direction, because it sucks the hot air So they found those people who introduced this fan into the market, they found a gap between the current state is rotating in one direction, and desired outcome. Desired outcome, so let's say there is another feature, it's noiseless, because they don't use the traditional fan, they use BLDC fan, BLDC motor. Okay. So uh, the so there is brushless. So normal motors, they have brush to maintain electrical connection. So it's a brushless. So it's a brushless. After ভালো জানেন, you have done 2 to 1. I did much earlier. So describe the gap between current state and the desired outcome, guiding the direction of the design process. Fill the gap. And it has to be solution independent. Problem statement has to be solution independent. That is very important with you all. কারণ মনে আছে those people who came yesterday to show their 3 ideas, they had their ideas. In their problem statement, the solution was built in. Solution was intended, built in. We have the built-in solution. For example, we consider a topic. Let's say we want to build a. So let's say we want to build a dryer. Dryer what? Dryer clothes. Let's say clothes dryer. So that's an engineering problem. So let's say you say that nowadays in this year we had plenty of. It must be a problem for all of us. We've seen plenty of rain. The sun was almost absent. Some of the clothes, if you wash it, takes, if it's quite heavy. Okay, that's the curtain of your windows, it got dirty, and you need to wash it. You washed it. It doesn't dry in one day. It's an engineering problem. আপনার মাই বলবে এই তুই কি ইঞ্জিনিয়ার হলি, এমন একটা ভালো একটা ড্রায়ার বানিয়ে দে। So not everyone have the ability to buy washing machine. It requires energy, it requires money. এখন আমার যদি ছাদে অ্যাক্সেস নাই, ছাদে even if I have access on the roof, the sun is not out, sun is not there. So maybe I can build a dryer. Maybe one of you can think that you're going to build a dryer for your FYDP. Okay, so এখন যদি বলি হ্যাঁ ড্রায়ার বানাবো, it's a problem. Is the solution is there? এর মধ্যে কি solution কোথাও? I want to build a dryer. The engineering problem is, yes, I want to build a dryer to dry clothes in the absence in the rainy season. So let's say its solution is mentioned somewhere. Solution is how it should be operating. It's a solution. এখন আপনি যদি বলেন, if someone comes to look, solar powered dryer, তার মানে হচ্ছে you are in fact suggesting the solution. I want a dryer. I'm going to decide what types of dryer is the efficient. Okay, efficient let's say in terms of economic efficient, consumes less power. I'm going to decide whether it could be solar power, it could be the brick power, it could be battery in terms of power. So I don't know the solution in terms of providing the power. কিন্তু আপনি যদি, if you go to your ATC with a topic which already says solar powered this, okay, smart this, artificial intelligence, তার মানে হচ্ছে কি আমি সলিউশনটা মেনশন করে দিচ্ছি, the way I want the solution will be provided is, so it has to be solution independent. আচ্ছা, তাহলে ফরম্যাটটা কি হবে? How are you going to write down the problem statements? আমি ফরম্যাটটা দিয়ে দিচ্ছি, please follow those formats. Okay, it has to be, first of all, start with the context, and then who needs what, because of why. Context, who, what, why. আমি একটা এক্সাম্পল দেই, that is coming from one of my FYDP group. They're currently doing their C. Okay, so the color is context, green, who, what, and why. First of all, the context. With climate change, soil degradation, and increasing water scarcity, sustainable food production has become a global priority. That context is done. Indoor and urban farmers using hydroponic systems. So the farmers, who? Farmers, who? That part is done. Okay. Why? Face challenges due to lack of effective monitoring and efficient resource management. That is what. And this color faces challenges due to which lead to suboptimal crop growth, excess water, nutrient usage, high reliance on grid electricity. তাহলে কি আমি কনটেক্সটটা বললাম প্রথমে, and কার দরকার, what it is required, faces monitoring, efficient monitoring, resource management. This is what required. And why? Because which lead to optimal growth. So that is what it should be. When you write down the problem statement, it must mention, you must very briefly mention the context, who needs it, who needs what. Like say that here dryer is what, context হচ্ছে ওই যে বললাম কি, কনটেক্সটের জন্য আমি কি বললাম, monsoon season, sun is not out, we don't have access to the rooftop, heavy clothes. This context. Why হচ্ছে আমাকে কাপড় শুকানো দরকার. So once you have prepared the problem statement, and this is how it has to be concise. It's not like that you write down 2 pages problem statement. Scope, you have to describe the scope. Scope tells you the boundaries of the project. The boundaries, what the solution will cover or include. So a good example is that scope. So let's say I've got an AC. I bought it, the AC for my one room. Okay, this is the room. I bought the AC. Okay, AC implemented. So what do you do? We always keep the door closed. When you turn the AC on, the door is closed. Do we keep the door open? After friend যদি থাকেন, after friend next রুমে থাকে, ওকে আমি একটু এসি কিনলাম, শুধু কেন আমি একা একা বাতাস খাবো, আমার দরজাটা খোলা রাখি, আমার ফ্রেন্ডও বাতাস খাবে. So here it is clearly you are violating the boundary, because this AC, you bought this AC, let's say 1 ton. You inform, you tell the people who sell the AC that this is the size of my room is eto by eto. So they made some calculations. Okay, your room requires a 1 ton AC, and you become very generous. You keeps your door open, so you expect that your friends should be also a recipient of those cool air. Because the AC, when it was built, it has a boundary. What is the boundary? Boundary should be this area. So the boundaries, so design scope. তার মানে হচ্ছে আমি যদি ড্রয়িং এর এক্সাম্পল দেই, can anyone tell me what could be the scope? So based on, আমি ঠিক বলতে পারছি না, আপনারা কি হেল্প করতে পারেন? স্কোপ আমি কি not only what you can include, what's covered, it or what is going to exclude. So when you're going to provide a solution, it's not necessary that you have to solve the problem of entire world. You have to be very specific. One of the scopes could be, let's say in dryer, it is not going to uh, let's say it so in terms clothes যদি বলি it can curtain. এখন আপনার মা যদি এসে বলে why don't you you know I have watched generally we don't do this আমি আমাদের গত বছরের যে লেপটা যে ছিল quilt now that you have built me a dryer আমি তো পর্দা ড্রাই করতে পারছি নাইসলি আমি ভাবছি আবার আমার লেপটা ধুয়ে দিব লেপ কি কখনো ধোয় অথবা কম্বলটা ধুয়ে দিব so you can say no it's not going to work so you have excluded certain things you have may include certain things so these are the scopes so you find out the things that you so that means it's okay if you cannot if your solution doesn't provide everything it's okay after you when you're going to define the problem you're going to find the solution if you find that beyond this it cannot provide any solutions okay you define the scope আপনারাই স্কোপটা ডিফাইন করবেন এর মধ্যেই এতটুকুই করবে not more than that there are many other things that can do okay for example it's an air cooler not air conditioner air conditioner is supposed to do the opposite thing as well so let's say in winter time it should provide warm water হিটারের মতো কাজ করতে পারতে পারে but the design scope doesn't include that I want something to cool not provide hot air so you decide the scope যে আমি এটা চাই not ওটা deliverables what the expected final output is that the final product that you it's your objective or the prototype or the model okay so stakeholders who is affected by the project who are the stakeholders for example if you get back to your dryer project how could you select the stakeholder বলেন তো who could be the possible stakeholder ধরুন আপনি একটা ড্রায়ার বানাবেন আপনি স্কোপটা ডিসাইড করছেন এনি আইডিয়া could it be for home use for industrial use
So home use.
তো তাহলে স্কোপ বললাম না স্টেক হোল্ডার্স আপনি একজন ইন্ডাস্ট্রি থেকে একজন বললো আমি একটা ইন্ডাস্ট্রি দিতে চাই ইন্ডাস্ট্রি মানে হচ্ছে যে একটা ওই যে ড্রাই ক্লিনিং সার্ভিসের মতো একসাথে 50টা কাপড় ইয়ে করে no it's only for home use isn't that would that be different if you want to build the things for only your mom or for some entrepreneur who got inspired by your own design so no right now I'm currently thinking about this is my scope okay and of course the constant look for okay let's say one of the example the project scope includes developing a compact modular prototype that they are saying you see so this project scope includes that is also from this group their concept note project scope includes develop compact modular prototype they already mentioned that this is what we want suitable for indoor setting particular for indoor farming the system will also include a basic user interface alert system allowing user to monitor conditions and receive notification if critical issues are caused that may or may not be considered as a scope I underline this but then I don't think it sounds like a scope so another project this project the last semester they got the top award for in the FYDPC scope of this project lies within the development of autonomous waste collecting robot for urban parks and fields I mentioned it urban parks not a football ground robot has to be capable of navigating terrains and collecting waste. However, the project does not include post-disposal waste processing. আমরা waste collect করব, but we are not going to process it. আপনাদের হয়তো সে বলতে পারে যে ওকে আপনারা তো কালেক্ট করছেন, why don't you process it? আপনারা বলে দিলেন that is beyond our scope. আমি বললাম যে if you can do something, it's not like that it's a shortcoming to your project. It's a deliberate choice. It's a deliberate choice that we're only going to collect garbage and we separate garbage, organic, inorganic. But we're not into processing or waste incineration or marketing activities. That's beyond our scope. So keep that in mind. Okay. Then we covered so far problem statement, then the scope, then objective. Okay. So what is that? Then that we have to write down your concept code. What is your design objective? A feature or behavior that design should have or exhibit or achieve. After the system, you build the system. What is the feature it should have? That is your specific outcome, specific goal. So in that case, it's going to, it's called, and that's such as a dry water, a dry cloth. Okay. So it is the design solution B rather than what it should do. You don't set design objectives, it should be written in such a way it doesn't tell what it does, rather what it is. It's a dryer. It's a dryer. Not it dries. So statement should be it's a dryer, it's a system, what it is, not what it does. Okay, so it includes an action verb, a specific target outcomes, or maybe have some measurable criteria. It must start with the action verb. Develop and implement an advanced monitoring and control systems. So that is the essential part. What it does is sets an action verb and specific outcomes in nouns. Develop and implement advanced monitoring controls to optimize. Okay, you can add this to optimize water, nutrients, energy uses in indoor hydroponic farming. Okay. Or design and develop an autonomous robotic system. Again, verb and noun. That collects waste for segregation into organic and inorganic waste. That is okay. It can also have measurable criteria. Okay, so it can say you can also some measurable criteria. Bolte paren it's going to collect to 10 kg waste. It's okay. So you can have action verb, specific target outcomes, and some measurable criteria of also condition. Let's say while it's a condition as well. You can also include condition. While minimizing power, minimizing just say energy consumption. So if you consider that minimizing energy consumption is one of the feature, it is okay to write it down in your problem statement, because if you are going to achieve something at the day, the dryer which dries with while minimizing energy consumption, so that we are considering that issue as well. Okay, so that's our design. Then these are the things that where you student struggle a lot in understanding and then executing. You have designed so far, it is the problem statement, and this is then the scope you have defined, and you have defined the objective, then the requirements. So the requirements essentially is the functional requirements, that the needs from the needs of the user is our requirement. Okay. Design requirements are a set of measurable condition and function. It's a function, so doing things that the design must fulfill to meet the objectives of the design. It describes how the objectives will be achieved. How? It's the how part. How the objective will be achieved. It serves as a benchmark to verify the final design. Generally, the requirement can be characterized. It can have three types of requirement: functional requirement. ওই যে আমি যদি বলি যে আমাকে একটা ফ্যান বানিয়ে দাও, what is the function? The fan should rotate. Okay, to give you air, give you wind. Okay, so this describes how the objective will be achieved. আমরা বললাম যে we want a dryer. This is its noun, and the verb form, it's dries clothes. How are we going to achieve? We use some solar powered heating system. How it is doing? Let's say first of all, functional. A statement of exactly what the design is expected to do to satisfy the objective. Functional requirement is important because you are going to design your entire thing based on what you have decided that your system is going to do, so that it satisfies the objective. The designs are expected to do. Okay, that is really important. Keep that in mind. So whatever the things you're going to decide at P, it has to be consistent in your D, and it has to be consistent in your C. So whatever the things you are doing, so make sure at the end of the day, it will be, when you don't see, you have to verify whether your requirements is satisfied that you defined in your P. Propulsion, action, verb, and a noun and objects. How are we going to write the functional statement? It must have an action, verb, and a noun. It reflects user's perspective mostly, what user wants. Again, it must be solution independent. So it can have two types of, so entire functional requirement can be broken down into two parts. One is the primary function or the basic function. So what the primary function is what the dryer do. Dryer dries clothes. Dries clothes. That's the primary function. That's what we want from the system. But inside, in order to build the dryer, we may have many components, many subsystems, which is essential to find this final outcome. So the basic function is the specific overall function that it must perform, drying clothes. So the dryer, which is your objective, is expected to do what? Dry clothes. Satisfy the objective. That's it. Secondary functions are, number one, the function needed to perform the basic function. A drying function achieve করার জন্য we need certain amount of things inside. We may have the power system, power source. We may have some communication things. We may have some introduce some sensors. We may have some mechanism. Use let's say we have decided to use some wire mesh, which when heated, it distributed the heat in such a way that in the presence of this, you have the clothes, it dries out. So it's that's a subsystem, how it operates. So that gives you the subfunctions or secondary function. That is also called the subfunction. We'll come to that soon. Subfunction. So this is functional requirement. Non-functional requirement. So one of the things you will find out that in your concept note, this structure is there. You have to write down functional requirement. Then non-functional requirement. Describe how well a system should perform its function. How well? Okay, it's providing drying. It dries. How well? So you have to quantify it. It's a good dryer, bad dryer, efficient dryer. So that gives you the, so let's say you can say it becomes 95% dry or 99% dry in 1 hour. The dryer dries and its efficiency is 99%. It focuses on performance rather than action itself. So আমি যে বলছি it's a 99% accurate কোন একটা জিনিস. Okay, so we are actually describing the performance. We're not describing the action itself. The performance, it could be speed, how fast. Okay, so in terms of fan, আপনার fan বললে জোরে ঘুরতে হবে. So in performance you can say okay 350 rpm. Okay. Response times, how quickly, so let's say how quickly it responds. Efficiency, accuracy, how accurate is that, how reliable is that. So those things that addresses is our non-functional requirement. This is requirement. Okay, that gives you an example. Remember we said what? It must have an action verb and a object or noun. Okay, for the functional requirement, for it has to start with action verb. So that's why we said traverse multiple terrains with advanced trekking. So this is what they have written. Okay, this is how it is written. Autonomous waste collection. Detects, sorts, categorizes waste efficiently. Send alerts to mobile app when the bin is full. In that, এটা দেখেন, it follows the structure, which must include a verb followed by a noun or object. The second one, it doesn't. Third one is all right. Detect, sorts, verb followed by, and then it says efficiently. So it has to be efficient. So that is our addressing the non-functional requirement. Sends alert, again action verb when the bin is full. এখন there's the and the functional requirement for the hydroponic group. They wrote it this way and they didn't write it right mostly. So they say uniform illumination of light for photosynthesis. So I said that it has to be in which way? It must start from a verb. So I would say instead of writing uniform illumination of light for photosynthesis, I'm going to say maintain uniform illumination of light for photosynthesis. So again, maintain, it's a verb, and uniform, what it classifies, the non-functional requirement. You might provide illumination, but আমি একটা টর্চ অথবা এলইডি বাল্ব দিলে আমি ইলুমিনেশন হয়ে যায়, লাইট হয়ে যায়, কিন্তু আমার কন্ডিশন ইজ হোয়াট? ইট হ্যাজ টু বি ইউনিফর্ম. So that is our non-functional requirement. They wrote water flow control. So that doesn't follow the structure of writing requirement. So I rewrite it. Control water flow. Again, verbs. Then nutrition and pH management. That's what they have written, which is wrong. Slightly redefining it. Provide necessary nutrition accurately. When I put accurately, that is all non-functional requirement. And same way, maintain adequate oxygen flow, regulate temperature, monitor. So you see, all of them starts with verb. So as I said, it must, okay, action verb and the noun and the object. So then it's a constant. So one of the requirement is the constant. Constant is also a requirement. It is a clearly defined non-negotiable limit or restriction that on the features of the behaviors of the design. Okay, so it's a constant. So let's say the constant is that um, you set the limit যে তার কম হলে আমি acceptable হবে না. We may have different limits. Different limits could be of different types. Okay. For example, আমি যদি বলি যে let's say the rover, which is traversing the territory, it must have আমি বলে দিতে পারি, it can have, one way it is requirement is that okay, its velocity is 20 meter 20 to 30 meter per second. That's a requirement. এখন আমি যদি বলে দেই it must have a velocity of 30 meter per second, তাহলে কি এখানে কি it's a range. It means it's okay if it is 25, it's okay it's 20, it's okay it is 30. So as long as my rover is maintaining this range, I am okay with the design. But if you say it has to be 30 meter per second, then if it is 31, not acceptable. If it is 29, not acceptable. If it's even 29.999, it's not acceptable. So this is the limit or the restriction on the features or the behavior of the design. So what the user needs or the design must satisfy, something is range is must satisfy. Now what types of identified sets of solution might otherwise meet the other requirement? There are some of the requirements, but it is unacceptable as limits are violated. আচ্ছা আমি দেখি আর কয়টা স্লাইড আছে. So time is okay. Do you have any class after 11? Does anyone have class after 11?
Class.
No, sir.
আচ্ছা আবার বলেন কারো কি ক্লাস আছে? আচ্ছা মেহেদি হাসান, you have class.
স্যার আমার ক্লাস আছে।
Yes, sir.
Okay. All right. I got the point. So I'll try to finish it as well as possible. So the constants has on it not only in terms of technical, it could be technical, physical, financial, regulatory, environmental. Financial means আমার এত টাকা নাই. Technical means okay, it has to be এত থেকে এত. Physical means size. Let's say you want to design a dryer. আপনি বলে দিলেন ড্রায়ার সাইজ তো বিশাল একটা বক্স হবে না, একটা রুমে একটা কর্নার, এটিকে আই এম গোইং টু প্লেস ইট. Size constraints. Just generally, when you place the washing machine, it's a very narrow place. So you cannot just build a dryer which is quite big. So you set the size. If you set the size, it has to be atto meter by atto meter, not more than that. That's a physical constant. And objective goals set the approximate. It's an objective goal sets an approximate level of the acceptable performance or characteristics that design want to achieve. A constant is absolute. Okay. আমি আগে বললাম যে constant technical, it could be performance, limit, size, weight, power consumption. You can say the power should not be more than atto watt. Economic could be budget, expenses, sustainable, whether it's sustainable or not. If the design said if it is not sustainable, it's not acceptable. Energy efficient, not acceptable. If there is carbon dioxide, this amount of CO2 coming out, not acceptable. Carbon dioxide emission should be within limit. Climate impact, or it's going to harm the climate in long run, not acceptable. So you're going to set it. Then regulatory safety standard. What safety standard do you need to follow? Industry codes, government regulation. Does it violate the government regulation? Yes, it does. So it is not allowed. It's not possible. Time. আমাকে ডেডলাইন দিল 2 weeks এর মধ্যে আমি একটা অ্যাসাইনমেন্ট দিলাম 10 days টাইম দিলাম ইটস এ কনস্ট্যান্ট 10th ডেতে এসে বললাম স্যার তো অ্যাসাইনমেন্ট করতে পারি না কিন্তু নো নট অ্যালাউড টু সাবমিট ইটস এ কনস্ট্যান্ট I can okay so LB growth so let's say space constant space for growth requires effective vertical horizontal plane to maximize ability so space size দিয়ে দিলাম এটা হচ্ছে constant they want uninterrupted power for their system to work continue perfectly they want uninterrupted power so does that mean it's a constraint power চলে গেলে হবে না I have to maintain uninterrupted power I have to maintain the standard I'm going to network connectivity and data transmission okay which protocol I should be using okay ঠিক আছে that's few example now another important is design specification okay? So specification এইটা হচ্ছে the খুবই important this is where students make huge mistakes the specification design set of constant or criteria that the design must satisfy and how the system will meet these functional requirements okay it must be quantitative and measurable and with a range of specific target value and must have units specification আর রিকোয়ারমেন্টের মধ্যে পার্থক্য হচ্ছে রিকোয়ারমেন্ট হচ্ছে আমাদের মেনলি ডেসক্রিপশন স্পেসিফিকেশন is the quantifiable limit that I want for example if I say I must have a fan which rotates is the requirement rotating is the requirement if I specify is that its maximum speed should be 300 rpm that is a specification so you have to build a fan you have to select the motors in such a way that your rpm is not more than 300 that's a specific so it must be quantitative measurable it must specification must have units once you are done again আমি কি বলছি আপনি p তে যেগুলি সিলেক্ট করবেন c তে গিয়ে এগুলি আবার জিজ্ঞেস করবো ওকে আপনাদের p তে তো এগুলি ডিসক্রাইব করেছিলেন দেখান তো দেখি have you satisfied those condition it derived from functional requirement non-functional requirement and constant আমি একটা एग्जांपल দিচ্ছি for example এই যে rover operates was traverse the rover functional requirement ছিল না rovers operate at a control speed of 0.5 meter per second to 1.5 meter per second আপনি দেখেন if you go back to the requirement it was the description traverse multiple terrains it was a requirement in specification it says how what is the numerical range it's a functional requirement system operates independently where it operates autonomously up to 30 minutes on full charge navigating the terrain without human intervention by utilizing a blah 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 at a response time of 0.5 seconds the functional both non-functional requirements are satisfied specified okay system must operate independently where it operates autonomously for up to 30 minutes is constant 30 মিনিটের মধ্যে যেন সে ফুল চার্জে ট্রাভেল করতে পারে ইটস এ কনস্ট্রেন্ট বিকজ আমি রেঞ্জ দিলাম না আমি সেট করে দিলাম system classifies waste with a minimum accuracy rate of 95% between organic and inorganic it's a again it must be able to identify the organic and inorganic material but what is the accuracy 95% it's a non-functional it's addressing the non-functional requirement collector takes lightweight object ranging from 500 grams to 3 kg so it's a specification rover is capable of handling elongated objects with dimension ranging from 10 centimeter to 10 to 27 in length and diameter okay it's the constant plus requirement waste collector performs within margin of error of 0.5% ensuring reliability process handling so this is how why specification important Because if you want to design, end of the day, you want to build a things. So let's say you want to build a, forget everything. Let's say you want to build a small car, just চারটা চাকা আছে। আমি যদি স্পেসিফাই করি that my car, the small toy car, should navigate or run with a speed of 0.5 meter to 1.5 meter per second. This is what I want. I specified it. So I have to select what? After build করার পরে আমি যদি দেখি আমার 5 মিটার পার সেকেন্ড যাচ্ছে, তাহলে কি will that be the one that I have specified to build? আপনারা বলেন, I have specified. আপনার ফ্রেন্ডে বলল আমাকে একটা টয় কার বানিয়ে দাও which will be traveling with a speed of 0.5 to 1.5. Now you build it and you found out it's, it is moving with a speed of 5 meter per second. So what does that mean? So you're not specific. You're not specific. আচ্ছা, I have to run fast. So যে ভুলটা সবাই করে, আমি এই ভুলটা আগে বলিনি। আপনাদেরকে যখন স্পেসিফিকেশন বলা হয়, most of the student in their presentation, they consider the specification of the component you may or may not use. Let's say আপনারা বলবেন আমি রাসবেরি পাই ইউজ করেছি, আমি এই মাইক্রোকন্ট্রোলার ইউজ করেছি, আমি এই সেন্সর ইউজ করেছি, আমি এই সেন্সর ইউজ করেছি, পাওয়ার সাপ্লাই 5 ভোল্ট 3 অ্যাম্পিয়ার USB-C. This is not the what specification is that. আমি এই সেন্সর রাসবেরি পাই ইউজ করেছি, আমি ওটা ইউজ করেছি, আমি ওটা ইউজ করেছি। দিস ইজ নট হোয়াট দ্য স্পেসিফিকেশন ইজ দ্যাট। আমি এখন বলে দিলাম, আপনারা জানেন, যদি দেখা যায় যে আপনাদের প্রেজেন্টেশনে পিতে, মনে রাখবেন, I will be in your P presentation. If I find any of those are doing this, হার্ড ডেজার্ট গান, কোনো অবস্থাতে যে কম্পোনেন্ট আমি যে ক্যামেরা ইউজ করব তার স্পেসিফিকেশন না, তার এত পিক্সেল বা এত পিক্সেল, ইটস নট এ স্পেসিফিকেশন। স্পেসিফিকেশনটা আপনার সিস্টেম যেটা করবে, দিস ইজ আওয়ার স্পেসিফিকেশন। Then finally you are going to do the functional analysis. That means you build the system. আমাকে just 5 minutes দিবেন, I'm going to wrap it up in 5 minutes time. 5 minutes টাইমের পরে যারা থাকতে চাবেন থাকবেন, if you have any issues, আর বাকিরা you can go. Okay, so once you have found out this functional requirement and non-functional, you're going to do the functional analysis. Functional analysis is the decomposing the functional requirement. আমি বলেছিলাম there are primary function or subsystem, sub-function. So you're going to determine sub-function. It's a functional relation between diagram consisting of blocks which represent physical components. Decomposition means হচ্ছে যে functional analysis divides a system into smaller parts called functional element or sub-function, which describe what the designer wants each part to do, but not how. আমি সরাসরি it should be verb noun represent. আমি সরাসরি এক্সাম্পল দিয়ে দিই। ফর এক্সাম্পল, ওকে, আমি একটা এক্সাম্পল দিই। লেটস সে you have to design a solar charging system for small electronic device. Okay, so we have to do the functional analysis. Then a basic function which is our functional requirement, convert energy. It's actually functional requirement, FR. So this is basic, convert energy into electrical energy. Set functions, what are secondary function? The secondary functions that are, it's going to do what? It is going to collect solar energy, one sub-function. Then it's going to regulate the power. Then it's going to store electrical energy, and then it's going to deliver output. আমি যদি মনে করি আমি একটা solar charger for my phone I want to build, I've got a solar cell and it's going to convert solar radiation into power so that my charge. তাহলে আমার এটা মেইন ফাংশন আর সাব ফাংশন। এখন আমি কি ফাংশনাল অ্যানালাইসিস বলি, এই যে চারটা পার্ট, এটা হচ্ছে আমার ফাংশনাল অ্যানালাইসিস ব্লক, চারটা ব্লকে। ফার্স্ট পার্ট হচ্ছে, ফার্স্ট প্ল্যাটফর্ম হচ্ছে ক্যাপচার সোলার এনার্জি, উই ক্যান ইউজ সোলার সেল, then regulate power plants, another sub function, then store electrical energy, another sub function, then finally deliver output power, so that you hook it up to your mobile phone. So সোলার প্যানেল থেকে আমার মোবাইল ফোন পর্যন্ত আমার এনার্জি কনভার্ট করার জন্য আমার এই সাবফাংশনগুলো আমাদের লাগছে। তাহলে ফ্লোটা দেখেন, চারটা ব্লকে আমি ডিসক্রাইব করলাম। সো এখান থেকে ফ্লো ইজ দ্য ডিরেকশন, দিস অ্যারো indicates the direction of energy or material flow. Normally system signal and material flow. In that case, the signal flows are taking place. So first of all, I'm going to use a solar panel. Then I'm going to convert solar panel to the energy. Okay. And then it's going to, regulate the power. And then this is going to charge the battery. And then the battery, from their battery, I'm going to do something that I get whatever the power required to charge my mobile phone. So this is a functional analysis. Now, খেয়াল করে দেখুন, they tell you what they are doing. Again, verb, capture, verb, store, deliver, all of them are doing, but they don't tell you how they are doing. They tell you what, not how. Okay, কোন কথা আছে? First part, another part is this is the last slide. The another part হচ্ছে you have to provide multiple solution. That the system that you are going to build, there it could be solved in a multiple ways, no obvious solution. তাহলে আমি এখান থেকে কিভাবে মাল্টিপল সলিউশন পাই? আমি তো দেখলেন চারটা সাব ফাংশন, তাই না? ক্যাপচার, রেগুলেট, স্টোর। এখন হাউ মেনি ওয়েজ I can capture solar energy? I can capture solar energy using polycrystalline solar panel or monocrystalline solar panel or thin film solar panel. That means there are three possible ways I can capture solar energy. Okay, next, regulate power flow. If I want to regulate power flow, what are the algorithm, what are the ways available? It could be PWM controller or it could be MPPT controller. So the two distinct ways are available. Okay, then store electrical energy. I want to store the electrical energy. How can we store the electrical energy? You see, I can use a lithium ion battery, I can use lead acid battery, I can use supercapacitor. So these are three ways I can store energy. Finally, deliver output. Let's say I have got only one option, I don't have what means 2 and means 3. So তার মানে দেখেন, if I go this and this, that gives you a possible solution. I can do this, this or this, that gives you a possible solution. I can this or this and this, that gives you possible. তাহলে খেয়াল করে দেখেন, আমি প্রত্যেকটা পারমিউটেশন কম্বিনেশন করে আমি কি করতে পারছি? I can provide multiple solution. So that would be our multiple design. Anyway, that's it. So I'm sorry, I think I needed more time. যাদের those who has class, what you can do, you can just write your ID in the chat box and then I can take leave. And others, for others, if you want to stay, you can, if you have any queries, I can. Yes. In fact, everyone write down your ID in your chat box, everyone. And those who have class, you can take it. Class is essentially over. আপনার যারা আছেন, যারা থাকতে চাচ্ছেন, I can give you some opportunity if you have. হ্যাঁ, হাসনায়না জুই বলেন, I can hear you.
Sir, it was by
Sorry?
Sir, it was by mistake.
Oh, sorry, that's fine. Anyone has any question? Again, I could have spent, if normal circumstances, আমার আরেকটু সময় দিলে হয়তো আরেকটু ডিটেইল যেতে পারতাম. Again, I'm not expecting, I'm not hoping that the thing that I delivered today is enough for you to understand everything. I'm sure and it's not at all enough. It is actually nowhere near to enough. আমি শুরুতে কি বলেছিলাম? I have covered the things what you have to learn. I'm not expecting that you are going to learn anything from there. I just touched upon the things that you have to dig yourself a lot. প্রত্যেকটা টপিকের আমি এখন আপনাদেরকে কি চাচ্ছি, আপনারা প্রত্যেককেই প্রত্যেকটা কনসেপ্ট, প্রত্যেকটা ডেফিনেশন, ইটস ইম্পর্টেন্ট টু নো দ্য ডেফিনেশন. Definition is something that connects people. You have a term, I hear a term, you hear a term. Unless we know the definition of that term, that we never agree on what understanding you develop about this term. You may have your own understanding, I have my own understanding. For example, when it comes to the objective, okay, objective শোনার সাথে সাথেই something comes in your mind, something comes in my mind, something comes in everyone's head. Okay, objective. এখন আপনার আন্ডারস্ট্যান্ডিং, মাই আন্ডারস্ট্যান্ডিং, whether they are aligned or not, কি করতে হবে? এটা করার জন্য I have to go to the কাজীর কাছে যেতে হবে। কাজী বলে দিবে যে this is the definition or of what objective means. Otherwise আপনিও অবজেক্টিভ, আচ্ছা অবজেক্টিভ ছিল, আমি অবজেক্টিভ, এটা actually will be speaking in two different wavelengths. I understand things in one way, you understand things in another way, but we're calling them using the same term. So which means that every term, I introduce many terms here. Okay, so every time I introduce, you have to spend time developing the understanding. For the ATC, next you are going to go to the ATC, and then it's quite normal, it's quite okay that you are fortunate enough that in your course curriculum these topics are incorporated. Now আপনারা যদি আমাদের next couple of years time you've joined as a faculty in our graduate department and you become a ATC member in one of this group, and the FYDP student যখন আপনার কাছে আসবেন তখন কিন্তু আপনি ইজিলি ক্লিক করতে পারবেন, ও স্যাররা তো আমাদেরকে এগুলি শিখিয়েছে. Maybe you would not remember those things, but you at least know the terms. But we are not fortunate enough like you. In our times, we didn't learn this thing. We did not have this thing. So আমাদেরকে শিখতে হচ্ছে. আমি শিখছি. I am a student myself. I don't have the authority of what I delivered today. I'm just as much as a student as you are. So আপনাদেরকেও ওই টার্মগুলি not only you don't think that আমি আজকে স্যার বলেছে সেগুলি আছে. Maybe your ATC, when you are going to next visit to the FTC, I would ask everyone that write down a kind of notes defining all the terms and then just hand it to your ATC. যে স্যাররা আমাদেরকে এই টাস্ক দিয়েছিল, এটা একটা হোমওয়ার্ক, আমাদের এই ডেফিনেশন, functional definition, functional requirement definition কি, this key, a definition key. Because when you're going to start developing your functional requirements or specification, you need to know what is the definition. Definitionটা যদি না জানি আমি কি করব, I don't know. And খুবই ভালো হয় যদি একটা যে কোনো একটা টপিকের কেস স্টাডি নিয়ে আপনারা ওয়ার্ক করেন. আপনাদের অফকোর্স সামথিং দ্যাট ইজ বিন অলরেডি ডান, যে হ্যাঁ ঠিক আছে, আমাদের ডিসপেসে FYDP রিপোর্টগুলি আছে, এই রিপোর্টার ইয়েগুলি আমি জানি না, মানে দ্যার ইজ ওয়ান গ্রুপ দে ডিড very good whether their materials available in the library or not. So or you just select any topic which is available in the net and how those topics are, or those terms are defined. Developer understanding is really very important. পিতে যা করবেন সেগুলোকে দিতে করবেন, দিতে কাজ সিতে যাবেন. Any question, any comment? So if you don't have any comments, questions, I think you can take leave.